Imagine a ruler obsessed with not just conquering the world, but with doing it in the most spectacular, awe-inspiring fashion possible. That was Adolf Hitler, an artist at heart, but with a twisted sense of grandeur that infected everything from architecture to military strategy. By the late 1930s, Nazi Germany was already on a collision course with the world, and Hitler's feverish imagination turned to one idea again and again: gigantism. Bigger ships, bigger tanks, bigger planes, because in his mind, sheer scale equaled unstoppable power. But this wasn't some personal quirk hidden behind the walls of the Reich Chancellery. It was a philosophy that seeped into the very bones of the Third Reich. Propaganda films showcased massive parades with columns of tanks, lines of thousands goose-stepping troops, banners that towered over city squares. It was all designed to intimidate, to project an image of overwhelming might. And the German military machine bought into it. Nazi engineers weren't just encouraged, they were outright instructed to think beyond the limits of conventional warfare. This led to monstrous tank designs like the Maus, aircraft carriers that never made it past the blueprint stage, and even plans for gigantic bombers capable of reaching America. Nowhere was this fetish for size more dramatically embodied than in artillery. Artillery had always been the king of battle. World War I proved that big guns could define the outcome of entire campaigns. So naturally, the Germans believed that if big was good, enormous must be unbeatable. That thinking wasn't entirely new. In fact, it had roots deep in European military history. The Germans remembered the massive siege guns of the First World War, like the Big Bertha howitzers that pounded Belgian forts into submission. Those weapons were technological marvels of their time, and their psychological impact was almost as devastating as their physical destruction. So when Hitler came to power, he resurrected this old notion on steroids. He wanted weapons so big they'd break the enemy's will before the first shot was fired. He dreamed of guns that could flatten fortresses, shatter defensive lines, and punch through any obstacle. This was more than just military pragmatism. It was theater. Hitler wanted the world to marvel at German engineering, to cower before its scale, and he wanted his generals and his people to believe that Germany could build anything, no matter how impossible it seemed. By the late 1930s, this ambition collided with real-world strategic needs. The Germans were drawing up plans to invade France, but they faced the daunting Maginot Line, an interconnected series of fortifications stretching hundreds of miles. Concrete bunkers, steel gun turrets, deep underground shelters. It was one of the most formidable defense systems ever constructed. The Wehrmacht's traditional artillery would be useless against such targets. Hitler demanded a solution: build a gun capable of destroying a French fortress from far beyond the range of enemy guns. In typical Nazi style, they didn't just want to crack the Maginot Line, they wanted to blow it off the map. Enter Krupp, Germany's premier arms manufacturer. When Hitler and his generals approached them, they didn't balk. They got to work, sketching out plans for an artillery piece unlike anything the world had ever seen. A gun so large, so powerful, that it would literally rewrite the rules of siege warfare. What they envisioned was insane by normal standards. A weapon that would weigh over 1,000 tons, fire shells heavier than a fully loaded pickup truck, and strike targets more than 20 miles away. It would be the culmination of every outsized German ambition rolled into a single, monstrous machine. And so, out of a toxic brew of Hitler's ego, Germany's industrial prowess, and the haunting lessons of World War I trench warfare, was born a project that would become legend: the Schwerer Gustav, or Heavy Gustav, the largest artillery piece ever built. But even in these early days, as engineers began scribbling impossible numbers onto blueprints, there was already a lurking sense that this dream might be more about spectacle than practicality. A superweapon designed not just to destroy fortresses, but to satisfy a dictator's craving for awe. When Hitler's demand for a fortress-killing supergun landed on the desk of Krupp's engineers in 1936, even the veterans of heavy industry paused. This was not a normal military order. The specifications read like something ripped from the fevered pages of a science fiction novel. The Reich wanted a gun capable of penetrating 7 meters of reinforced concrete, or 1 meter of hardened steel armor, the kind of protection the French had poured into the Maginot Line. And it had to do it from at least 25 miles away, far beyond the reach of counter-battery fire. In Essen, Germany, the Krupp Company had been building cannons since before the Franco-Prussian War. They were masters of metallurgy, forging breech blocks and barrels for everything from light anti-tank guns to the 800mm railway howitzers of the Great War. But even for them, this was uncharted territory. Dr. Erich Müller, Krupp's chief designer, took the challenge personally. Under his guidance, teams of draftsmen and metallurgists began to sketch out a monster. To breach the French defenses, physics dictated an absurd scale. A caliber of 800mm, that's roughly 31.5 inches across the barrel's internal diameter. Compare that to the American battleship guns of the day, which topped out at about 16 inches. This would be double that size. And the shells? Each would weigh between 4.8 and 7.1 tons, depending on the type. Some were designed to smash through concrete, others to explode inside bunkers, sending lethal shock waves down corridors. The sheer forces involved were mind-boggling. When fired, the gun would unleash over 80 tons of propellant gases, pushing the projectile out of the barrel at nearly 2,700 feet per second. The recoil would be so enormous that a traditional gun carriage was impossible. Instead, Gustav would have to ride on twin parallel railway tracks, spreading the load over dozens of axles. The German military command, particularly the OKH, watched eagerly as Krupp's plans took shape. This was more than just a weapon. It was a symbol of German engineering supremacy, a tool of psychological warfare before the first shell ever landed. By 1937, Krupp had completed the initial design studies and provided the scale models to Hitler's staff. The Führer was reportedly ecstatic. He examined the miniature with the enthusiasm of a schoolboy unwrapping a toy train set. Hitler's fascination with technical drawings and mechanical minutiae meant he was involved himself directly, poring over cutaway diagrams, peppering engineers with questions about shell weight and range. Then came the daunting reality, building it. Even with Krupp's advanced foundries, casting a barrel over 100 feet long and weighing 400 tons pushed the limits of metallurgy. Specialized steel had to be developed to handle the immense pressures without cracking. Heat treatment alone took weeks, as the enormous mass had to be brought to temperature uniformly, then slowly cooled. The internal rifling, the grooves inside the barrel that spin-stabilized the shell, posed yet another challenge. Traditional methods would take years on something this size. Krupp built custom machinery with massive cutting heads that crawled through the bore on hydraulic arms, shaving and polishing the steel to a precise pattern. By 1939, with Europe teetering on the brink of war, the first full-scale components were taking shape in Essen. Hitler visited the Krupp works personally, donning a hard hat and beaming at the gigantic steel rings and the incomplete barrel sections arrayed like cathedral columns. The Germans dubbed it Schwerer Gustav in honor of Gustav Krupp von Bohlen und Haublach, the elderly patriarch of the Krupp dynasty. In Nazi propaganda films, the name took an almost mythic resonance, an unstoppable titan of steel that would obliterate enemy forces with a single shot. It was around this time that the first doubts crept in. Wehrmacht's logistics officers began quickly calculating the requirements. Thousands of workers to lay special rail lines, vast stockpiles of ammunition, dedicated repair crews, and anti-aircraft defenses just to protect the gun. Moving it from one location to another could take weeks, an eternity on the fluid battlefields of the 20th century. But by then it didn't matter. The project had inertia, pushed by Hitler's personal enthusiasm, by Krupp's desire to secure lucrative contracts. The contracts ran into millions of Reichmarks, feeding a vast industrial ecosystem that Hitler was loath to interrupt. So the work continued. By early 1941, the main body components were finally ready for assembly and test firing. The result was not just a weapon, but a mechanical leviathan unlike anything the world had ever seen, a chilling monument to the Nazi regime's obsession with scale and spectacle. The birth of the Schwerer Gustav in the Krupp workshops was only the start. Forging the barrel, machining the breech, and manufacturing the massive bogies were monumental feats of industrial might. But it was the assembly and deployment where Gustav truly revealed its monstrous scale, and where the staggering demands of Hitler's obsession came fully to light. By the time the final parts were completed in 1941, The gun was no longer just an engineering marvel. It was a logistical nightmare that would consume men, materials, and rail lines wherever it went. The fully assembled Gustav weighed 1,350 tons. To put that in perspective, it was heavier than a fully loaded modern aircraft carrier's island superstructure, or roughly 17 fully fueled M1 Abrams tanks stacked together. The barrel alone stretched 106 feet, 32.5 meters, so long that it needed multiple rail cars simply to support its length. It was so heavy and unwieldy that there was no crane in the world capable of lifting it in one piece. Instead, Gustav had to be shipped in dozens of major components, each placed on specially built flat cars. Once it arrived at a staging area near the front, the gun was painstakingly assembled on site. This wasn't a matter of a few days of setup. Full assembly took over 3 weeks, even with a force of up to 2,500 men, including engineers, laborers, and armed guards. Before Gustav could even be assembled, the Germans had to build an entirely new stretch of twin railroad tracks, reinforced with tons of gravel and cross ties just to bear its enormous weight. A secondary spur line was constructed parallel to the main track, allowing the gun to be moved laterally, essential for aiming since the gun itself could only adjust elevation, not traverse side to side. If the target moved, the Germans would literally have to shift the entire weapon on rails. Gustav also required a massive infrastructure tail. Ammunition depots had to be constructed to store its titanic shells, each weighing between 4.8 and 7.1 tons and standing nearly 10 feet tall. Special gantry cranes and rail-mounted lifts were brought in to hoist the shells and propellant charges into position. The shells themselves came in several terrifying variants. The most common high-explosive type carried a bursting charge of 1,200 pounds of explosive filler, capable of leaving a crater large enough to swallow a small house. Armor-piercing rounds could bore through 80 feet of earth or 30 feet of reinforced concrete before detonating. Each shot was a colossal endeavor. The crew would hoist the shell onto a special loading platform, slide it into the breech, and follow it with multiple silk powder charges. Once the gun fired, the concussion was so intense that no one could be within hundreds of meters of the weapon without risking permanent injury. Observers described how trees nearby would shed all of their leaves from the shockwave, and windows in surrounding villages would shatter. Even maintenance was epic in scale. After every few shots, the barrel had to be cleaned and inspected for microfractures. A full barrel replacement was anticipated after about 300 rounds, though in practice Gustav never came close to firing that many. Supporting this steel behemoth was an entire field army of logistics. The Germans established dedicated anti-aircraft batteries to protect Gustav from Allied bombers. Supply trains carried replacement parts, welding rigs, spare tracks, fuel, rations, and living quarters for the thousands of personnel assigned to the gun. The sheer spectacle of it all wasn't lost on the Germans. Nazi propaganda units eagerly filmed the assembly and firing sequences, producing short newsreels that played in theaters across the Reich. These showed sweating crews hammering giant bolts into place, cranes lifting steel segments of the size of subway cars, and finally the enormous recoil as Gustav belched fire and smoke. Yet beneath this spectacle lurked serious vulnerabilities. The gun's immobility was its Achilles heel. Once deployed, it was effectively anchored to its custom track. If the Allies discovered its position, it would be a sitting duck for air attacks. Even moving Gustav to a new firing site could take weeks of dismantling, rail reconstruction, and reassembly. Hardly a weapon suited to the fast-moving mechanized campaigns that defined World War II. Still, to the Germans, particularly Hitler, none of this seemed to matter. Gustav wasn't just a weapon. It was a monument to Nazi willpower, a thunderous declaration of German industrial supremacy. By early 1942, after years of planning, forging, shipping, and assembling, Schwerer Gustav was finally ready to roll towards its first and only combat mission. By the spring of 1942, after years of forging steel and assembling parts the size of houses, Schwerer Gustav was finally ready to go to war. But moving a 1,350-ton artillery piece wasn't simply a matter of hooking it up to a locomotive and chugging off to the front. Transporting Gustav was a colossal military operation in itself. an entire campaign of rails, manpower, and secrecy before the first shell was ever fired. The journey began at the Krupp plant in Essen, where Gustav had been assembled in segments. The massive barrel, the breech block, the recoil system, the enormous undercarriage, all were loaded onto specially constructed rail flat cars. In total, Gustav's transport convoy included 25 or more separate cars just for the primary gun components, not counting the dozens more carrying cranes, workshops, fuel, spare parts, ammunition, and even a sleeping car for the workers. The German army dedicated an entire rail regiment to the Gustav's movement. They laid down reinforced twin tracks, often tearing up existing lines and rebuilding them to carry the immense weight. Bridges sometimes had to be strengthened or even bypassed by laying fresh track across open fields. Security was another massive undertaking. The convoys moved under heavy guard, with armed infantry riding in armored cars and motorcycle scouts clearing the route ahead. Anti-aircraft batteries were dispatched alongside the train to protect it from prying Allied reconnaissance aircraft. At night, the convoy often halted and was covered with camouflage nets, while nearby anti-aircraft guns set up defensive positions in case of surprise attacks. But even once Gustav arrived in the combat zone, the real ordeal began. The site selected for its combat debut was near Sevastopol, the heavily fortified port city in the Crimea. The Soviets had turned the region into a near impregnable fortress, with vast concrete defenses, underground bunkers, and coastal artillery designed to repel entire fleets. For Hitler, it was the perfect opportunity to showcase his monstrous gun. Getting Gustav into firing position required building brand new rail system on the spot. German engineers constructed a 1,200-meter-long double track, specially graded and reinforced to distribute Gustav's titanic load. Parallel lines were laid so the gun could be moved side to side for aiming, since Gustav had no ability to transverse horizontally on its own mount. Adjusting left or right literally meant dragging the entire gun assembly on the tracks. The manpower requirements were staggering. Up to 4,000 men labored on site to prepare the gun for action. This included rail engineers, artillery specialists, signal troops, fuel handlers, cooks, medics, and construction battalions, an entire small city devoted to operating a single weapon. A huge camp was built around Gustav's position. Ammunition depots stored the enormous shells under camouflage netting. Machine gun nests, trenches, and barbed wire were thrown up in concentric rings. Flak batteries were installed to shoot down any Soviet aircraft that might discover this vulnerable monster before it could fire. Even communication lines had to be specially arranged. Dedicated field telephone networks and radio links connected Gustav's observation posts, some of which were stationed miles away on high ground, equipped with powerful rangefinders and binoculars to spot targets and correct fire. Because when your shells travel over 30 miles, even the slightest miscalculation in an angle could mean missing the target by hundreds of meters. Once the gun was finally assembled on its new rails, the next challenge was calibration. Firing test shots wasn't just about checking aim. Each discharge exerted stress on the barrel that had to be measured and compensated for. Teams with gauges and stethoscopes inspected the barrel after each round, listening for cracks or warping that could spell disaster if left unchecked. And all of this moved with agonizing slowness. Shifting the gun to aim to a new target could take hours. Resupplying Gustav with shells and propellant charges was a ballet of cranes, loaders, and crew working in precise sequence. Each shell had to be hoisted into place by special cranes, slid into the breech by hydraulic arms, and carefully aligned. Propellant bags followed, carefully packed in exact quantities to achieve the desired muscle velocity. The Soviets would soon find out just what this enormous effort was meant to accomplish. But even before the first shell crashed into Sevastopol, Gustav was already a living testament to the Third Reich's doctrine of intimidation through sheer scale. It wasn't just a gun, it was a rolling spectacle, a psychological weapon as much as a physical one. Allied intelligence reports buzzed with rumors of a monster gun, capable of leveling entire city blocks. The legend was already growing. Yet, under all this Nazi bravado, seasoned Wehrmacht officers worried. The entire operation was painfully inflexible, dependent on vulnerable supply lines and static firing positions, in a war that was becoming increasingly mobile. Gustav was the very opposite of blitzkrieg: slow, obvious, and potentially catastrophic if caught by an enemy bombing raid. Still, in June 1942, the preparations were finally complete. Gustav was loaded, aimed, and ready to announce its terrifying arrival on the world stage by hammering Sevastopol's mighty fortress into rubble. It was June 5, 1942, when Schwerer Gustav finally spoke. After years of feverish design, forging, transporting, and assembling, Hitler's gargantuan cannon was ready to unleash hell on the besieged city of Sevastopol. The Crimean port was one of the most heavily fortified places on Earth. Soviet engineers had transformed it into a sprawling network of underground bunkers, coastal artillery batteries, concrete casemates, and hidden ammunition stores, many cut straight into the rocky hills. Conventional shelling and air raids had proven largely ineffective, but Gustav was not conventional. The Germans had chosen this fortress for a reason. They wanted to break the Soviet lines and secure the Black Sea. But just as importantly, they wanted a live demonstration of Nazi technological supremacy. The propaganda value of their supergun was enormous. Newsreel crews were on hand to capture every monumental firing. At first light, the immense gun crew sprang into motion. Cranes lifted a 7-ton shell nearly 30 feet around at the base, swinging it over to the loading tray. A hydraulic ram slowly pushed it into the yawning breach. Then came the propellant bags, some 400 kilograms of powder carefully packed and sealed. The breech was locked, crews took cover, and the firing circuit was connected. When the firing order came, Gustav did not merely fire, it erupted. A tongue of flame dozens of feet long belched from the muzzle. The ground for hundreds of yards quivered. Observers standing miles away felt a concussion slam into their chests. Windows rattled in towns across Crimea. The entire steel leviathan rolled back on its specially laid rails, then settled again. The first shell flew nearly 30 miles, curving over German lines and plunging deep into the rocky hills of Sevastopol. Moments later, a dull, distant thunder rolled back, a delayed signal of catastrophic impact. Spotters peering through binoculars watched a great geyser of rock, dust, and shattered concrete erupt from the target zone. What exactly did these giant shells do? They weren't just bombs. Gustav's primary rounds were designed to penetrate 30 feet of reinforced concrete, or nearly 100 feet of packed earth before detonating. The Germans targeted ammunition bunkers and underground command posts, trusting that the shock waves and fragmentation would devastate everything within. One famous strike was against Fort Stalin, a powerful Soviet stronghold with multiple levels of subterranean magazines. A single Gustav shell is believed to have pierced deep into the rock and detonated, causing secondary explosions that effectively erased the fort from the battlefield. Later, Gustav would fire on Fort Molotov and other hardpoints, helping to break the Soviet morale and resistance. Over the course of the bombardment, Gustav fired 48 shells. Each shot was an enormous enterprise. After firing, the barrel had to be swabbed, inspected for microfractures, and sometimes realigned. Firing more than just a few rounds per day simply wasn't possible. Yet despite this ponderous pace, the psychological impact on the Soviets was devastating. German intelligence reported intercepted radio traffic filled with panic and confusions. Soldiers described enormous explosions that seemed to come from nowhere, obliterating entire platoons underground. But for all the headlines, the actual strategic impact was more modest. Sevastopol's fate was sealed by combined operations: Luftwaffe dive bombers, relentless conventional artillery, infantry assaults, and clever infiltration tactics that bypassed many strongpoints. Gustav contributed enormous local damage, to be sure, but it was not the war-winning hammer blow Hitler liked to imagine. Meanwhile, each shot Gustav fired placed it in jeopardy. Soviet reconnaissance aircraft were constantly searching for the gun's position, and Red Army planners desperately wanted to destroy it with counter-battery fire or air raids. The Germans wrapped Gustav's sight in an umbrella of flak guns and camouflaged it with netting and smoke, but everyone understood it was only a matter of time before the Soviets zeroed in. By early July 1942, with Sevastopol in German hands and the immediate need past, Gustav's immense machinery was disassembled. The crews loaded the barrel, breech, and supporting structure back onto their specialized trains and began the slow trek out of Crimea. In total, Gustav had done exactly what it was designed for, blown apart heavily fortified position from ranges unthinkable for ordinary artillery. But it had also proven every criticism from skeptical Wehrmacht officers. It was too slow, too expensive, too vulnerable, and required a staggering logistical circus to operate. It was a weapon of spectacle more than a true strategic necessity. Yet even then, the legend was sealed. Nazi propaganda broadcasts crowed about the giant gun that smashed Soviet fortresses to dust. Films showed its mighty shells being loaded and the earth-shattering recoil that followed each shot. To the average German citizen, Schwerer Gustav was proof of Hitler's unstoppable might. To the Allies and the Soviets, it was a grim reminder of what Nazi industry could dream up, and a fresh incentive to develop bombers that could reach it. Gustav's first and only true battle was over, but the gun itself would remain a rolling monument to the twisted marriage of engineering genius and totalitarian obsession. A machine built to embody terror as much as to deliver destruction. If the sheer size of the Schwerer Gustav was enough to awe casual observers, it was the physics behind each shot that truly boggled the mind. Gustav was not just the largest artillery piece ever fielded, it was also one of the most extreme experiments in the destructive potential of gunpowder, steel, and gravity ever conducted. The gun's caliber of 800 millimeters made it the largest rifled artillery piece ever built. For comparison, the massive American Iowa-class battleships fired 16-inch shells. Gustav's bore was nearly twice as wide, and the shells exponentially heavier. The most common projectile was the 7.1-ton high-explosive shell, roughly the size of a small truck. It carried over 1,200 pounds of explosive filler, more than a dozen typical howitzer shells combined. When this massive shell left the barrel, it did so at nearly 2,700 feet per second, meaning it covered a mile in just under 2 seconds. The physics were staggering. The kinetic energy of one Gustav shell at muzzle velocity was around 400 million joules, roughly equivalent to detonating 100 kilograms or 220 pounds of TNT purely from velocity, before even accounting for the explosive warhead itself. That's enough kinetic force to smash through layers of reinforced concrete or rock simply by brute momentum. The most terrifying were armor-piercing shells, designed specifically for fortress busting. These weighed about 4.8 tons, slightly lighter so they could be propelled faster, concentrating their impact energy on a smaller point. Engineers crafted them with hardened caps and delayed fuses, meaning they wouldn't explode on contact, but would instead punch deep into the ground or fortifications before detonating. When these shells hit, they could penetrate 30 feet of reinforced concrete or 100 feet of earth before exploding, causing catastrophic underground collapses and shockwaves that cracked bunkers open like eggs. By the time Schwerer Gustav finished bombarding Sevastopol, its limitations were glaringly obvious to many in the German high command. What had started as a dream of unstoppable firepower, a rolling fortress breaker that could level any defense, had become a living demonstration of how bigger doesn't always mean better on the modern battlefield. Gustav was a spectacular engineering achievement, but it was also painfully impractical. Every feature that made it awe-inspiring was also a crippling liability. Mobility was its first fatal flaw. Unlike smaller railway guns that could roll across standard tracks and fire with minimal preparation, Gustav needed its own specially built twin rails, reinforced to handle its weight. Shifting it even a few degrees to adjust aim meant laying down parallel lines. Moving to an entirely new target area could take weeks of dismantling, transport, and reconstruction. In an era where the German army prized speed, blitzkrieg tactics that depended on rapid armored thrusts and flexible artillery support, Gustav was the very opposite, lumbering, slow, and logistically strangling. Vulnerability was the next problem. Once assembled, Gustav was an enormous sitting duck. A reconnaissance aircraft, or even a clever scout on the ground, could spot this colossal gun from miles away. The Germans understood this, which is why they surrounded Gustav's site with entire regiments of anti-aircraft guns. They laid down camouflage nets, smoke generators, and flak towers, but in reality Had the Soviets managed a concentrated air attack, Gustav could have been destroyed by a few well-placed bombs or sabotage raids, wiping out years of investment in a single afternoon. Then there was the operational strain. It took an army to keep Gustav functioning. Thousands of workers, engineers, security troops, logistics handlers, and maintenance specialists formed an entire mini ecosystem just to service the gun. The shells alone required a dedicated production line, specialized railway cars, and cranes to lift them. Every shot demanded hours of preparation, meticulous cleaning, barrel inspections, and calibration. In a fast-moving war, this was simply unsustainable. Even its firing was problematic. Each shot from Gustav was spectacular, but also broadcast its position to anyone within 50 miles. The muzzle flash and dust could be seen from distant observation points. After firing, the barrel needed careful inspection for microcracks. Overuse could destroy the rifling or cause catastrophic failure. So ironically, the Germans couldn't even unleash Gustav at full tempo. They had to ration its firepower carefully, undercutting the very overwhelming devastation it was built to provide. Finally, there was the cost. The Reich spent millions of Reichmarks on Gustav. It soaked up industrial capacity that could have produced hundreds of conventional field guns or tanks. Each of those could move rapidly, be hidden, repositioned, and supported combined tactics far more effectively. The opportunity cost of Schwerer Gustav was immense. In the end, Gustav was a paradox. It worked exactly as designed, smashing deep fortifications at Sevastopol, terrifying defenders, creating enormous craters. But it was also a relic of an earlier military philosophy, better suited to static sieges of the 19th century. World War II was a war of maneuver, rapid exploitation, and air dominance. In that world, Gustav was a dinosaur. Hitler, of course, was largely blind to these limitations. He remained fascinated by gigantism, dreaming up even more ludicrous projects, from the 1,000-ton Land Cruiser P-1000 Rat super tank to conceptual naval guns that could fire shells between continents. None of these ever progressed beyond drawings, because by then even Nazi engineers understood the bankruptcy of such ideas. For seasoned officers on the Eastern Front, Gustav was little more than a propaganda totem, a frightening psychological weapon, but one whose strategic impact didn't match the resources it devoured. It consumed coal, steel, manpower, railway capacity, and time, all things increasingly scarce by 1943 as Germany's war fortunes waned. So while Gustav's shells certainly collapsed bunkers and cracked open underground fortresses, the gun itself became a lesson in military hubris, proof that building the biggest didn't necessarily mean building the best. In the end, it stood as a towering monument to a regime's obsession with spectacle over substance. When Schwerer Gustav finished its thunderous work at Sevastopol in mid-1942, it left behind more than just smoldering bunkers and shattered Soviet morale. It also left German high command with a question no one quite knew how to answer. What do we do with it now? Hitler, ever enamored by symbols of monstrous might, wanted to keep the Gustav ready for more sieges. The Wehrmacht planned to redeploy it for operations against Leningrad, another fortress city where such a gun could theoretically blast open defenses that months of traditional artillery bombardments had failed to crack. In fact, in the summer of 1942, Gustav was moved north by rail to positions near Leningrad. But fate and the Soviet Union's tenacious defense intervened. The front lines around Leningrad remained unstable. Roads and rail lines were under constant threat of partisan attacks, and Soviet air raids increased in frequency. The logistical puzzles of assembling Gustav again under such dangerous conditions proved too risky. The operation was quietly shelved. So Gustav was shuttled back into Germany for maintenance and storage. In 1943, it was partially disassembled and hidden in places like Rügen Island and Thuringia, moving now and then to avoid Allied air reconnaissance. Crews still maintained it, tested mechanisms, and even produced new shells. There were idle plans to bring Gustav back into action if another fortress needed leveling. But by then, the tide of war had shifted dramatically. As the Allies advanced from the west and the Red Army from the east in 1944 and 1945, Gustav became less a symbol of Nazi grandeur and more a glaring liability. It was too big to hide, too precious to let fall intact into enemy hands. The last months of the war saw desperate efforts by German forces to cover their tracks, destroying documents, sabotaging factories, and even scuttling ships. Sometime in April 1945, with Soviet forces pushing deep into Germany, Gustav's caretakers were ordered to render the gun unusable. Accounts differ on the exact location. Some place it near Auerbach in Saxony, others closer to the Czech border. But most historians agree that German engineers and demolition teams blew up the main barrel and key breech components, ensuring it could never fire again. Its giant steel remains were left scattered along the railway embankments. When Soviet troops arrived days later, they found twisted fragments of Gustav's once proud barrel, shattered bogies, and scattered shell casings. The Red Army took extensive photographs and even removed some pieces back to the Soviet Union for study. There was no question the weapon had been real. Its wreckage was unmistakable. In the years that followed, the story of Schwerer Gustav took on a life of its own. Soviet newspapers published triumphant images of captured Nazi superweapons, using Gustav's corpse as proof of Hitler's insane militarism. Western military intelligence pored over the reports, partly in awe, partly to reassure themselves that no nation would ever again try to field something so impractical. But as with all legends, rumors also blossomed. Some claimed Gustav's twin gun, Dora, had been hidden intact in an alpine tunnel. Others insisted that Gustav itself had only been partially destroyed and was spirited away by the Soviets to test its monstrous shells on a secret proving grounds in Siberia. No credible evidence ever surfaced for these tales. They were products of the same fascination with gigantism that had created Gustav in the first place. A world unable to let go of the idea that such a titan might still lurk somewhere, waiting to roar again. In the end, Gustav's fate was as tragic and wasteful as its existence. A triumph of engineering brilliance yoked to the dark service of a brutal regime. Its twisted remains lay rusting under German skies for decades. A silent testament to the folly of building weapons not for strategic necessity, but for psychological theater. And so Schwerer Gustav passed into history, not as the superweapon that changed the course of the war, but as a colossal cautionary tale, a story of steel and ambition gone mad, where the dream of absolute destructive power outstripped all common sense. Today, its few surviving fragments in museums stand as cold reminders of just how far humanity is willing to go to build engines of war that impress more than they achieve. In the end, Schwerer Gustav left behind a legacy that was paradoxical. At once a monument to human engineering audacity, and a sobering lesson in how easily that audacity can slip into folly. The sheer scale of Gustav has ensured that it remains one of the most famous artillery pieces in history. It still fascinates military enthusiasts, model builders, historians, and casual readers alike. There's something almost mythical about a gun that could fire a 7-ton shell over 30 miles, a machine so vast it needed its own army just to function. Yet for all its fame, Gustav's operational impact on World War II was astonishingly small. It was, as many historians have concluded, an industrial ego project, a device that offered psychological terror, dazzling propaganda footage, but very little in actual strategic return. Sevastopol fell as much to infantry assaults and Luftwaffe bombing as it did to Gustav's shells. And in the years after the war, no serious army ever again pursued an artillery piece on remotely the same scale. The death of fortress warfare played a big part. By the late stages of World War II, fixed fortifications had been largely outpaced by mobility, air power, and armored warfare. Blitzkrieg had shown that static lines could be bypassed or neutralized by maneuver. Even in the Cold War, when NATO and Warsaw Pact forces faced off across Europe, neither side dreamed of building a new Gustav. The future was tanks, missiles, and tactical aircraft, mobile, flexible, and lethal in ways no gigantic cannon could ever hope to be. Yet Gustav did influence thinking in an unexpected way. In the 1950s and 60s, superpowers shifted their dreams of titanic destructive power from giant guns to intercontinental ballistic missiles and strategic bombers. These were, in a sense, heirs to the same psychological intimidation. The ultimate weapons meant to break an opponent's will by sheer scale of devastation. Unlike Gustav, however, missiles could strike anywhere on the globe in minutes. They didn't require laying thousands of feet of track or guarding rail convoys for weeks. On a technological level, Gustav remains an engineering marvel. Metallurgists still study its forging processes, barrel castings, and recoil absorption systems. Museums across Europe display fragments of Gustav shells and components as testaments to what human industry can achieve when told to make the impossible real, without ever asking if it should. Perhaps most fascinating is how Schwerer Gustav has lived on in popular culture. It appeared in everything from World War II documentaries to video games like Call of Duty, where players storm beaches under fire from massive railway guns, to anime and alternate history novels that revel in oversized war machines. These fictional Gustavs often do what the real one could not: move easily across terrain, fire rapidly, and turn the tide of battles. In that sense, Gustav has transcended its own failure, becoming a kind of modern myth, the ultimate big gun that haunts our collective imagination. But in sober military studies, Gustav's story is told very differently. It's a cautionary tale about prioritizing spectacle over strategy, about sinking vast resources into weapons that exist more to intimidate and impress than to actually win wars. It stands behind other monstrous Nazi superweapons, like the Maus tank and proposed 1,000-ton land cruisers, as examples of how the Third Reich's mania for gigantism often betrayed its fundamental strategic needs. Today, the few twisted fragments of Schwerer Gustav that survive, rusting sections of barrel, pieces of its massive reach, rest quietly in European museums or in forgotten, overgrown lots. They draw curious onlookers who marvel at their size, sometimes unable to believe such a thing ever existed outside of science fiction. And maybe that's the truest legacy of Gustav, not as a revolutionary war machine, but as a sobering monument to human hubris. A story of how, under the shadow of tyranny, brilliant minds can be directed to build monsters that are breathtaking to behold, terrifying to contemplate, and ultimately useless when real history demands results, not just scale. I thank you for watching. Please consider subscribing. I'm Dave Newton. Follow me for more amazing military history.